Learning outcomes. After studying this module, you will be able to know about some advanced techniques used in forensic toxicology, their principles and methodology, and their forensic importance and applications. So, dear students, let us start with the introduction of this module. Analytical chemistry is a science immediate to physical chemistry, which is a subdivision of pure chemistry. The objective of analytical chemistry is basically to improve and apply innovative approach and instrumentation with the aim of providing information on the nature and composition of matter. Analytical chemistry, moreover, permits the determination of a structure of the compound either partially or completely in samples of differing complexity. Finally, the role of analytical chemistry is to provide an interpretation of the results obtained. Chemical analysis contains the use of instrumentation to elucidate an analytical problem. The use of instrumentation has currently become a part of chemical analysis and is applied for all areas of pure and applied science. One single instrument could not solve an analytical problem. As an alternative, several instrumental techniques are required to solve the problem to a maximum extent. Therefore, instrumentation plays an important role in the production and estimation of different products and in the protection of users and the environment. In instrumental examination, a physical property of a substance is evaluated to determine its chemical composition. Analysis may be biochemical, analytical, inorganic, organic and physical. Whatsoever may be possibly the type of analysis, the objective of the analysis is to provide information about the composition of sample. This is called the quantitative analysis, and this analysis can only be imagined by using instruments. The selection of the instrument depends on the property to be measured. During the selection of method, the concentration of the sample and accuracy required must be taken into consideration. The concept of instrumental analysis reviews the countless advantages and limitations of the same. It is crucial to understand about the advantages and limitations of every instrumental technique. The development of technologies has led to the development of high-performance instruments carrying innovative and comprehensive prospects, especially hyphenated and non-destructive methods. Non-destructive tests can be conducted on very small samples that do not require wide sample preparation prior to the measurement. Now, students, we will be studying about electrophoretic techniques. Electrophoresis may be stated as the migration of colloidal particles through a solution under the effect of an electric field. When a potential difference is applied between two electrodes in a colloidal solution, the colloidal particles are carried to either the positive or the negative electrode. Electrophoresis is the motion of dispersed particles relative to a fluid under the influence of an electric field. Electrophoresis is the best recognized electrokinetic phenomena. It was discovered by Reus in 1809. Electrophoresis occurs because particles dispersed in a fluid practically always carry an electric surface charge. Electrostatic Coulombic force is exerted on the particles because of the charges in the electric field. The rate of travel of the particle depends on the characteristics of the particle, the properties of the electric field, the system temperature and the nature of the suspending medium. In recent past, the capillary electrophoresis has emerged as a promising technique in forensic science. In forensic science, the capillary electrophoresis is used for the analysis of illicit drugs, gunshot residues or GSR, explosives, opiates and drugs in biological materials like urine, blood, viscera and other biological fluids. Capillary electrophoresis, or better known as CE, is an electrophoretic technique or an electrophoresis performed in a capillary tube. Capillary electrophoresis is a very sensitive separation method which has been developed mainly through the experience acquired from the high performance liquid chromatography or HPLC, thin layer chromatography or TLC, and from the electrophoretic methods. Biomolecules and compounds of lower molecular mass are difficult to study by HPLC or the classical methods of electromigration on slab gel becomes separable by capillary electrophoresis or the capillary electrophoretic technique. The most often used modes of capillary electrophoresis are: first is capillary zone electrophoresis or CZE. This mode of electrophoresis, in which the electrolyte migrates through the capillary, is the most widely used. In this mode, samples are applied as a narrow band that is surrounded by the electrolytic buffer. This electrolyte can be dependent upon the application, acidic or the basic, or an amphoteric substance. The electroosmotic flow increases with the pH of the liquid phase or can be rendered inexistent. In capillary zone electrophoresis, electrophoretic separation is based on plain electrophoretic mechanism in free solution. Capillary zone electrophoresis is also referred to as a free solution capillary electrophoresis. It is the most widely used method since it is applicable to separation of anions and cations, not the neutrals, in the similar run and comparatively simple. The second type is Micellar electrokinetic capillary chromatography or MEKC. In this variant of capillary zone electrophoresis, modified to the separation of neutral or polar molecules, a cationic or anionic surfactant, example sodium dodecyl sulfate, is added in excess to the background electrolyte to form charged micelles. These small spherical species, immiscible in the solution, form a pseudo-stationary phase analogous to the stationary phase in HPLC. They trap neutral compounds efficiently through hydrophilic or hydrophobic affinity interactions. Neutral molecules as well as ionic species can then be appropriately separated as a direct result of their solubilization within the micelles. MEKC is useful to perform chiral analysis. This involves the addition of a cyclodextrin as a chiral selector to the running buffer. Optical purity analysis can be determined due to the formation of inclusion complexes between a hydrophobic portion of the solute and the cavity of cyclodextrin having different stabilities. Third is capillary isoelectric focusing or CIEF. This technique consists of creating a constant and linear pH gradient in a surface treated capillary which has been filled with a solution that contains ampholytes or Zwitter ions. Capillary isoelectric focusing is a focusing type of capillary electrophoresis in which the solutes, commonly proteins, are separated on the basis of differences in their isoelectric points, that is, at characteristic pH. The solution in the capillary is then forced past the detector to generate the electrophoregram. The vial that contains the cathode is filled with a catholyte, a basic solution, and the vial that contains the anode is filled with an analyte and an acidic solution. Next, we will be studying about capillary gel electrophoresis or the CGE technique. This technique represents the transposition of the classic agarose or polyacrylamide page gel electrophoresis into a capillary. The capillary is filled with an electrolyte impregnated into a gel. This produces a filtration effect which decreases the electroosmotic flow and minimizes convection and diffusion phenomena. Fragile oligonucleotides can be separated in this way. CGE has been adapted to DNA sequencers. Special instruments, fully automated, have been designed with multiple capillaries that can simultaneously analyze various samples through a fluorescent-based detection. The modified technique is known as capillary array electrophoresis for the separation of the DNA or RNA fragments based on their size. The next type of electrophoresis is capillary isotachophoresis or CITP. This is a moving boundary technique in which the sample is sandwiched between two buffers. The output in capillary isotachophoresis is different from the other modes in that the zone widths are proportional to the amount of ions in the sample. Capillary isotachophoresis is sometimes used as a sample pre-concentration step. Anions and cations are usually not separated in the same run. Next is inductively coupled plasma or ICP. Inductively coupled plasma sources are used largely for metal analysis on a broad selection of sample types. Inductively coupled plasma or ICP is generated from radio frequency magnetic fields induced by either water or air-cooled copper coil looped around a quartz tube. Higher powers are usually applied when organic solvents are aspirated. Argon gas flows through a torch which contains 3 concentric tubes generally constructed from fused silica. The plasma is instigated by directing the argon stream with electrons provided from a Tesla coil. The electrons detached from the argon atom collide with argon atoms and crowd the coil region with positive and negative charges. As a result of the magnetic field, the particles flow in a closed annular path. Due to the conductance of the gases in the coil regions, the charged particles are heated by inductive coupling to a temperature equaling ionization of the argon gas occurs, and resulting is the formation of the ICP. The plasma impedance is checked along with the data of the tube grid current, grid voltage, plate current and voltage to control the plasma power. Since there is no straight wired connection between the plasma and the energy source, it is called as inductively coupled plasma or ICP. Next, we will be studying about solid phase microextraction or SPME technique. Solid phase microextraction or SPME is a very simple and efficient solvent-less sample preparation method invented by Polizin in 1989. Solid phase microextraction has extensively been used in various fields of analytical chemistry since its major applications to environmental and food analysis, and is perfectly suited for coupling with mass spectrometry or MS. Solid phase microextraction is an extraction technique for organic compounds in aqueous samples in which the analytes are adsorbed directly from the sample onto a fused silica fiber that is coated with an appropriate stationary phase. When the fiber is inserted in the sample, the analyte portion from the sample matrix enters the stationary phase until equilibrium is reached. The fiber is then inserted into the injection port of a gas chromatograph or GC, where it is heated and the analytes are rapidly desorbed thermally into a capillary gas chromatograph column for analysis. Next is radio immunoassay or RIA. The technique was introduced in the year 1960 by Burson and Yallo as an assay for the concentration of insulin in plasma. Radio immunoassay, or better known as RIA, is a sensitive in vitro nuclear medicine technique used to measure concentrations of antigens without the need to use a bioassay. Although the RIA technique is extremely sensitive and extremely specific, it requires specialized equipment but remains the least expensive technique to perform such tests. It requires special precautions and licensing since radioactive substances are used. Today, it has been superseded by the ELISA method or the LSR technique, where antigen-antibody reaction is measured using colorimetric signals instead of a radioactive signal. However, because of its sturdiness, dependable results and low price per test, the RIA methods or techniques are again becoming popular. The RAST, or better known as radioallergosorbent test, is an example of radioimmunoassay. It is used to detect the causative allergen for an allergy. Radioimmunoassay is based on the antigen-antibody reaction in which trace amounts of radio-labeled antigen competes with endogenous antigen for limited binding sites of the specific antibody against the same antigen. In principle, radio-labeled antigen should be similar in bioactivity and or immunoreactivity of the native antigen. Although radioimmunoassay is the oldest and still a commonly used immunoassay technique, it remains to offer distinctive advantages in terms of their easiness, sensitivity, management and efficiency. RIA or radioimmunoassay was the forerunner of heterogeneous immunoassays. Difficulties associated with the handling and storage of radioactivity, disposal of radioactive waste and the half-life of radioactive labels have resulted in RIA being replaced largely by non-isotopic methods. Next, we will be studying about nuclear magnetic resonance or NMR. Nuclear magnetic resonance is one of the branches of spectroscopy in which the radio frequency waves induce transitions between magnetic energy levels of nuclei of a molecule. The magnetic energy levels are formed by placing the nuclei in a magnetic field. Without the application of magnetic field, the spin states of nuclei are not different and the energy level transitions do not take place on application of magnetic field. Transition between energy levels takes place. Nuclear magnetic resonance has given its name to a very significant method of resolving the problems of structural determination for organic compounds and for certain types of inorganic material. NMR spectrometers are therefore often located in research laboratories, although more uncomplicated instruments exist in manipulating the same principles for routine applications. Countless nuclei may be studied by NMR technique, but hydrogen and carbon are most frequently available. NMR provides information about the number of magnetically distinctive atoms of the type that is being studied for. The NMR is useful instrument for forensic science laboratories also and has been used in analysis of explosives, drugs and other organic samples. Now students, let us summarize this module. Analytical technique could be defined as an essential scientific phenomenon that has proved useful for providing information on the composition of substances. Chemical analysis includes the use of instrumentation to solve an analytical problem. The use of instrumentation has nowadays become a part of chemical analysis and is applied for all areas of pure and applied science. Instrumentation plays an important role in the production and evaluation of new products and in the protection of consumers and the environment. In instrumental analysis, a physical property of a substance is measured to determine its chemical composition. Electrophoresis is the movement of electrically charged particles or molecules in a conducting liquid column or medium, usually aqueous, under the influence of an electric field. Inductively coupled plasma sources are used primarily for metal analysis on a wide array of sample types. Radioimmunology has remained the method of choice for certain studies of clinical medicine and has few applications for the measurement of molecules of low molecular mass because of the use of radioactive substances. NMR is one of the branches of spectroscopy in which the radio frequency waves induce transitions between the magnetic energy levels of nuclei of a molecule. The Magnetic energy levels are formed by placing the nuclei in a particular magnetic field. Thank you.